Welcome back to Arxflix. Today, we're diving into a fascinating paper that explores the question: do large language models, LLMs, perform multi-hop reasoning without explicit instructions? This research delves into the inner workings of LLMs to see if they can connect and reason through implicit knowledge stored in their parameters. Imagine a prompt like, "The mother of the singer of superstition is." The paper investigates whether LLMs can 1. Identify the singer of superstition as Stevie Wonder, and then 2. Use their knowledge of Stevie Wonder's mother to complete the prompt. Let's break down how they explore this. While LLMs excel at in-context reasoning when information is explicitly provided, they often struggle with multi-hop reasoning when the information is implicit. This paper aims to understand if LLMs can bridge this gap by leveraging latent knowledge within their parameters. To study this, the researchers created a dataset called 2-Hop Fact. It contains 45,595 unique pairs of 1-hop and 2-hop prompts, covering 52 different fact composition types. This dataset allows for a comprehensive analysis of multi-hop reasoning across diverse scenarios. The paper introduces two key metrics. 1. NTREC. This metric measures the LLM's internal recall of a bridge entity, like Stevie Wonder, based on its descriptive mention in a prompt. 2. SONSTA score. This metric measures the consistency between the LLM's responses to a 2-hop prompt and its corresponding 1-hop prompt. The researchers investigated whether changing the prompt to indirectly mention the bridge entity increases the LLM's internal recall of that entity. They found strong evidence for this first hop of reasoning, especially in larger models. This figure shows the relative frequency of cases where the internal recall of the bridge entity increased when the prompt was modified. As you can see, the blue bars indicate a higher frequency than random chance, suggesting that the LLM is indeed performing the first hop of reasoning. Next, they explored whether increasing the LLM's recall of the bridge entity improved its utilization of that knowledge to answer the 2-hop prompt. They found moderate evidence for this second hop of reasoning, but it didn't scale as strongly with model size. This figure shows the relative frequency of cases where increasing the bridge entity recall led to increased consistency in the LLM's responses. While the blue bars indicate some evidence for the second hop, it's not as pronounced as the first hop. Combining the results for both hops, the researchers found moderate evidence for latent multi-hop reasoning in LLMs. While the pathway exists, it's highly contextual and not consistently used across all prompts. This figure shows the relative frequency of different outcomes for the first and second hops. The green bars represent successful multi-hop reasoning, indicating that both hops were performed. While the frequency is above random chance, it's not overwhelmingly high. This research provides valuable insights into the latent reasoning abilities of LLMs. While they demonstrate some capacity for multi-hop reasoning, there's room for improvement. Future research could focus on optimizing pre-training data, loss functions, and model architectures to enhance these capabilities. This paper highlights the complexity of LLMs and the need for further exploration to unlock their full potential for reasoning and knowledge representation. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow researchers. See you in the next one. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.